So in this video we are going to discuss about the collision theory after the lock and key model. Collision theory. For example, I'm having a container and here I'm having the molecules, gaseous molecules. So for example, I'm making two molecules of them. So when it will strike with this molecule, it will transfer the energy. So the energy of this molecule will transfer into this molecule. So this molecule will be having the lower energy because of it has strike with that and it has shifted to that. So we are having the two type of a molecule in the beaker. First is that the energy of reactant. Here it is also the energy of reactant. Some of the molecules is having the average kinetic energy, which means less kinetic energy, and some is having the higher kinetic energy. Some molecules having the higher kinetic energy. It means that if there is no proper collision, so which means there will be the not effective collision will be there, which means the chemical reaction cannot start. Not effective collision, and here there are more collisions, so here the reaction can be developed, and the collision is just because of the collision is there of the more kinetic energy. Here the effective collision will be there. Alright, so if we talk about the, for example, I'm having a beaker here I'm having some molecules, so I'm giving temperature to that molecules which are having the average kinetic energy. So this molecule will gain the energy from this temperature, and the collision will be occur and the reaction will be start. Collision will occur and reaction to be start, and there will be the rate of reaction to be increased. So a higher kinetic energy to be increased by the temperature. So we can see that not effective collision will be developed, plus after temperature it will develop. Alright, if we talk about this, for example, this is a container and this molecule is having the more kinetic energy, so they will attract with each other because of the more energy, and they will repel with each other because of the less energy. Alright, so we are having the two type of molecules and less. One thing I want to tell you guys is that we are having the two type of a reaction in the container. First is the exothermic, second is the endothermic. What does it mean? In this, the, for example, reactant into the product, reactant will be having the more energy and the product will be having the lower energy. For example, I'm making a graph here. This is the reaction path, and here is the energy of the reactant. So energy of the reactant to be getting lower and the product will be produced. For example, here the product is reactant is A into B, so the product will be B. So energy will be less when the product will be appeared. So in the product the energy is lower, and in the reactant the energy is more. So more energy into the reactant, and that will be converted into the product, and product will be stable because of the irreversible reaction, because there is only one reaction to be occurred. Here the product will be having more energy, Watch, for example, I'm having the graph here, I'm having the energy. So here I'm having the reactant, but that is having not more energy, so which means I will be giving the temperature, alright, to start the energy or to start the reaction. So this will be here the molecules will be getting the energy and the reaction to be start, and the product will be produced. So you can see that the reaction is start, so the energy will be released to the product, means product will be having the more energy. Alright, more energy to be absorbed, so there will be the more energy, and the reaction will be, this is unstable, and the product will be unstable, and that will be having the in product will be unstable, so that can come back to the reactant, which means it is a reversible reaction. Here it is not coming back, here it can come back because of the unstable. Here it is stable, it cannot come back. So we are having the two type of a reaction, exothermic and the endothermic. So this was about the collision theory.